I heard that. Is it not the case that d squared is equal to the sum of the squares of the other two sides? Oh, you know what, you guys? We better take a break. Hold it. It's just measured in feet. You want to convert this to miles per or feet per hour?
Feet per second.
Or feet per hour?
Yeah, feet per.
No, I asked, do you want to?
Let's change that one. Change it to miles.
Yeah, I agree with you guys. I think it's too much work because this is clearly 2 miles. So, I think, rewriting everything in terms of miles, d squared is equal to the sum of the squares of the lengths of the other two sides. Minus twice the product of the length of the other two sides. Times the cosine of the included angle to those two sides.
No wonder they said you're going to put a whole 60.
Say it again.
60 degrees?
I can't hear you.
Yeah, 120.
There you go. You guys agree?
Wait, why is it 2 times x?
Well, I think, watch.
Oh, 2, okay, you said 2 times, okay, never mind.
2 times the product of those two sides. You guys, the law of cosines is just an extension of the... no, it's just an extension of the Pythagorean theorem. Or saying it backwards, the Pythagorean theorem is a particular case of the law of cosines. After all, if this angle right here has measured 90 degrees, the cosine of 90 degrees is 0. So the second term drops out, and you just get the Pythagorean theorem, don't you? The square of the hypotenuse is 7 squared of the two sides.
We could still do this problem even if we have the law of cosines memorized, though, right?
Oh yeah, you can always rederive that thing here. Yes, a piece of cake. Well, you guys, I still haven't answered my darn question. If I'm going to try to find d, let's you and I take a break. Differentiate both sides of x to t. And I think 2d, d, is equal to
0
plus
2x dx dt.
minus
2 or 4
4
cosine
cosine
120
120 degrees
times negative sine or dy.
dx dt. Or differentiating.
It's just like it died immediately.
Why is that times dx dt?
Because I'm differentiating x. I'm differentiating the constant times x, which would be the constant times dx dt.
Oh, yeah, okay.
So don't you have to also multiply that by the derivative of cosine 120?
No, because that's just a constant coefficient.
Oh.
As a matter of fact, why don't you and I take a
Yes.
break and call it what it is? What is the cosine of 120? I asked, what's the cosine? I asked, what's the cosine of 120? Negative. Negative.
Negative 1 over 2?
Negative.
1/2.
Negative 1/2. Thank you.
Yeah, that's you.
Oh, actually, I can just divide both sides by 2, if you guys don't mind. Yes, Ryan.
Like where goes negative 2 to x, like in the top line? Where'd the x go?
It didn't. It's not that it went anywhere, but to differentiate x squared, I wrap my fingers around the 2.
No, I mean, go 3 numbers to the right. There's another x.
Where'd that one
Yeah, where'd that one go?
Ryan, do you agree with this? That this whole term is just as constant times x,
Okay.
but its derivative is going to be that constant. Oh, there it is. Times dx dt.
Okay, I got you.
Well, I'm the one who just differentiated. Let me take a snapshot in time with my mathematical camera, slap everything in. At this one particular point in time, I don't know. You guys help me with this. What is x? What is
It
x?
changes.
I know, but at this one point in time, what is
You're
x?
making 60 miles per hour.
360 miles per hour times how many hours?
3 minutes, so
160.
1/20th.
3 over 360, which is 1/120th. So first piece of scratch paper, decide. After 3 minutes. I think x is going to be nothing more than the rate at which it's changing, which is 360 miles per hour. Times how much time has just passed by, which is 3 minutes. Oh, shoot, the minutes don't cancel with the hours. I got an idea. I'll multiply by another fraction before I got minutes downstairs and hours upstairs, so I get my desired cancellation. So question, is 60 hours equal to 1 minute? No, but 1 hour is equal to...
60.
You guys, my point is, I don't have to worry about whether I'm dividing or multiplying by 60, just plug in the values. Oh, but shoot, here my 60 and 360 will cancel, and I'm merely left with 6 times 3 miles. Or shall I say just simply 18 miles? Oh, that's nice. Now I can come back over here in my equation, I can slap in for x. I better change colors because I'm fading. Hold it. I think at this one moment in time I can slap in for x my 18 miles. At this one point in time, what's dx dt?
360.
360. Plus 360. And I've got my d dt. Are you happy that I finished? Everybody.
Yeah.
Wait, hold on, don't you need D?
Where's D?
Okay, I'm not finished at all. There's a missing factor d. Shoot, I don't have it. I got an idea. Let's come in and pull out a second piece of scratch paper. And let's find d. Oh, you know what? It's a piece of cake. Because I think with the original picture, using the law of cosines again, I think that original picture tells me that d squared is equal to my 2 squared plus x squared minus twice the product of 2 and x with the cosine of 120 degrees. It's just at this particular point in time, x is going to be 18. So I guess it tells me that d squared is equal to 2 squared plus x squared minus 2 times 2 times, I misspoke, didn't I? Why didn't I misspeak? I just meant x at this point in time is 18. Minus 2 times 18 times the cosine of 120. Or shall I say, d squared is equal to 4 plus 18 squared minus, I don't know, or plus 36. You guys aren't going to help me. Is that a 2 times the square root of 1 plus 81 plus 9? So d is equal to 2 root 91. Oh, what can I do with 91? I don't know. I'm thinking about that.
Nothing. It's a prime number.
7? No,
No, I'm saying it's not a prime number.
it'd be the 7.
Oh,
But 7 goes in how many times?
It doesn't matter, I'm just saying it's not a
Oh.
number.
13.
Yes, 7 times 13. Okay, I can't break it down further. Assume my arithmetic's correct. Alright, I think it is. I just double checked my arithmetic. So I think at this one point in time, I got a value for d, which is 2 root 91. I'll plug it in. Here's a 2 root 91. Now solving for d dt, I think that d dt is therefore going to be something divided by 2 root 91, but what's the something?
19 times 360.
Thank you. Or shall we say d dt is nothing more than the 180 times 19 over root 91. You guys, I'm just curious. Is anybody willing to compute this in a calculator? I don't know what the value is.
20 times 180.
It's like 358.5134 on to infinity.
Oh, shoot. Does that make sense?
How many?
Yes.
Sorry, how did you get 360 times
You know, I'm so lazy. I saw this as 360 times red beast, 360 times red beast. You know, in my head I factored out at 360. And what's left over is red plus red. I'm so lazy, I just try to find shortcuts.
Oh, okay.
Look at my answer. Is that logical?
Yeah.
Why?
When we're talking about the distance, it's climbing vertically.
Well, I think I'm trying to find the rate at which d is increasing. Does it seem reasonable it should be close to that rate of change?
Wait, shouldn't it be greater though?
Oh, I think because it's larger, it should be a little less than that rate.
Oh, okay.
But I think it should be really close to it for this reason. Look, at this one point in time, x is 18, really big. This length is 2. And so with this really elongated triangle, I think x is pretty darn close to the value of b, and therefore the rates of change should be pretty darn close. And check that out, they are. Don't take this the wrong way, I still could have made a mistake numerically, but I think I'm in the ballpark. I think those values should be close to each other. Do you guys agree? Number 4 is kind of nice, but you know, it's kind of a business application. Might not be that quite exciting for you guys because most of you are physics and engineering majors, I assume. How many of you are engineering majors? Physics. Math. Oh, thank you.
Computer science, close enough.
Computer
Computer
science.
science.
This biology is a good one. Oh, wait. You guys know flatlanders, right?
Doesn't exist.
Flatland?
Are you talking about the book? Like,
Yes, the book, Flatland.
Oh.
You guys have never read Flatland?
I remember you telling us about that.
Oh.
That's the extent of my knowledge of
Wait,
flat.
what's flatland? Tell us.
Oh, never mind.
Guys, you're science majors. Everybody in this room should be reading Flatland.
That, you got a point.
Are you guys familiar with how arrogant mathematicians are?
Yeah, they named it.
Very snobbish. We think we're the best of the best. All that kind of garbage. During the 1880s, a lot of people were talking science fiction. A lot of people were talking about four-dimensional space. And the leading mathematicians globally at the time were at Cambridge University. And they got so incensed by that, they all made a public declaration. They made a declaration in the papers saying, we're sick and tired of hearing these ignorant people in our society in England talking about four-dimensional space. We're the leading mathematicians. There is no such thing as four-dimensional space. And some man was also so incensed by the arrogance of the mathematicians, he wrote a book called Flatland. And here's what the book is. Its main character is a square, which is only two-dimensional. And the square lives in its plane. And one day, there's a sphere who comes by and he's really, really bored, so he tries to talk to the square. Now, relative to the square down here, what does the sphere look like? See, I think it looks like nothing. He can't see it. Because the square lives in two-dimensional space, it can't see up or down. It's only a two-dimensional creature.
Wouldn't
So
you just see a point?
he would see nothing if the sphere is up here.
No, you can't look up to see it.
Because he's not a three-dimensional creature. So the square thinks he's hearing voices. Well, the sphere is still bored, so the sphere decides to touch the universe, the space in which the square lives, and all of a sudden, poof, out of nowhere, it appears a little dot. But then the sphere continues talking to the square as he passes through the square's universe, which is just a two-dimensional plane. So here's what's going on. As time goes by, he's hearing voices, and all of a sudden, poof, a dot appears, and it grows a bigger and bigger circle, and then gets smaller and smaller, and then poof, disappears, all the meanwhile, the sphere is still talking to it. So the square is really feeling like it's going crazy. But you and I reading this, we're three-dimensional creatures. We fully understand the limitations of the square since he's only a two-dimensional creature and we're three-dimensional creatures. We live in the same space as the sphere. And since we can see the limitations of the square in observing a higher dimensional object, then maybe we shouldn't be so restricted with us as three-dimensional creatures identifying what a four-dimensional object looks like. This is the year 2013. I don't have to play this game anymore. I've got a nifty computer. I can generate what it looks like to have a four-dimensional object pass through a three-dimensional universe. I can do that rather easily on the computer because I've got the mathematical number crunching capability.
This is a whole book.
Oh yeah, it's a very short book. It's a book, I promise you, pick it up, you can't put it down.
Who wrote it?
It's a short book, but it's not.
I've got a first edition, and if you look at it, there's no author's name. He was
No
a
author.
clergyman. He was a little too embarrassed that it might get him into trouble, so he didn't put his name on the original book. But subsequent editions he did. His name is Abbott. A-B-B-O-T-T.
Or Abbott?
Abbott. If you Google search Flatland, the first thing that pops up is the actual book. It's for free. It's so old. 1886. Man, no one in this room has read Flatland.
I've heard of it.
Wait, so
Now
what
that you talk
happened?
about it.
That's all.
What happens is that the square gets so confused, he decides, I can't make any sense out of this. And all of a sudden, the square runs across the one-dimensional object. So now the square starts understanding, this one-dimensional object can't be what I look like. So maybe I should understand that a three-dimensional object surely can exist. For you and I argues that a four-dimensional object exists. There are other issues in the story, you should read it, because women are horribly degraded in the book. So you either think that this guy is an absolute sexist bigot, or maybe he's trying to write or maybe he's trying to shake up saying, look at how women are treated in England in the 1880s. It also describes class structure, how degrading that is to individuals.
I know there's like a 20 or 30-minute movie that they made on it.
Don't you dare see it. No, don't even. Don't. It's so poor. Don't even.
So,
There is a really good science fiction book. I just love this thing. Called The Hitchhiker's Guide to the Galaxy.
Yes.
And the movie that came out was so horrible. It was just terrible.
What's the answer to life, the universe, and everything?
Did you really?
Yeah, you should read the book.
it's like,
I've read the book.
Homework.
I just
You guys, I think the rest of you can take a peek at it. I did the most important ones. So the homework last time went up through section 3.8.
Yes, correct.
You guys can take my comments seriously. You really should sometime when you get a chance. You gotta read them.
Does that mean that four-dimensional space exists in your...
For me as a mathematician, absolutely yes. Even higher dimensional space exists.
Well, isn't that sort of theoretical, though? I don't hear voices or like...
Because I can build equations involving four-dimensional objects. I
But
think
since you can model it, that doesn't necessarily mean that it exists. I can model a lot of stuff that doesn't exist.
true, but if you can well, I don't know. I take it back. I think if I can mathematically model something to me, that suggests it exists. I'm not an empiricist. I'm not a physicist. I don't claim I have to see it to be able to.
Okay, so until the mathematicians start getting this.
And it talks about the aliens that see in fourth dimensional space, they look at a book, and they just see all the images in the book at once. And they read the entire story at once, and they see like, time isn't linear, so like.
That's true.
Why the book is
You see someone like, as a baby to an old man, like as a giant centipede, that's fourth dimensional, like. It is a cool concept, just the idea that you can read a book just by looking at like all the images at once.
No, just no.
Change is weird.
It's called, this gaze is the collective scorn of the internet. This gaze.
Where there will be a quiz on Wednesday?
Sure.
On what?
3-8.
3/8?
Oh, are you interested in a take-home quiz?
Sure.
I got a good one up here.